Hey guys, welcome back to another episode of Math Unlocked. I'm your host, Mrs. Rhodes-Grierson. So, if you're hearing this video, you would have watched the video on inequations, how to read your inequations. You'd have also watched the video on solving inequations. Now we have a special inequation where our focus in this inequation is the fact that the coefficient of the variable is a negative number. This affects our solution in a very big way. So I want you to stay tuned with me, come all the way as we unravel why is it that when you're told that the inequation, if the coefficient of the variable is negative, why is it that at the end we need to flip this sign to make the solution that we get for y true, to make the solution true? So come with me. Now, if you have a statement like this that says negative 2y plus 1 is greater than 7, and it says solve, it means that you want to get the variable by itself on one side of the statement of the inequality sign, one side. So right now I have two terms right here, and there's my core. I want to get this by itself. There is this negative 2 that's multiplying it, and I'm adding 1 to the term that is here. Now, how do I get the y by itself? I'm going to peel my onion. So you would have, if you're here for the first time, maybe you have not heard about the onion method, but here's my core, and these are the rings around my core. So the first ring is this one, the second ring is that one. When we peel the outermost rings first. We peel by undoing the operation. So if this was addition, we can peel it by subtraction. But remember that there was an inequality sign here, which means that whatever you do to one side of the expression, you need to do it to the other side. So we reduce this expression by subtracting 1. We have to reduce that side by subtracting 1 to make the statement true. So now that created 0. What happens now is that I have negative 2 is multiplying my y, and that's greater than 6. Now, I need to get this negative 2 that's multiplying y from y, and the opposite of multiplication is division. So we're going to divide both sides by 2. Both sides. Whatever you do to one side to keep that balance, you need to do it to both sides. So this is now removed to leave us with y being greater than, and this would be negative 3. But let's look at, so we're going to pause right here to see if this statement is actually true, and why is it that we may need to change this sign. Let's explore it. If the statement says y is greater than negative 3, we're going to do some substitution. If you have not watched my substitution video as yet, you want to check that out to ensure that you are clear as it relates to how to substitute. So what was our original statement? Our original statement says negative 2y plus 1 should be greater than 7. We got a statement that says y is greater than 3. So I'm going to check a number. I'm going to choose a random number. Remember that when we look at inequations, if y is greater than negative 3, y could have multiple values. A number is greater than negative 3. Let's look at our number line. So if we have negative 3 greater than, we're going right. So we look at negative 2, negative 1, 0, 1, and we can go on into infinity. I'm going to choose one of these. I'm going to just choose a random one. I'm going to choose negative 2. So if y is greater than negative 3, then I could say y could be equal to negative 2, negative 1, 0, and all of that. So I'm choosing the first one. Let's choose y to be negative 2, and we're going to substitute to see if that would make this statement true. So negative 2 is multiplying negative 2. If y is negative 2, that is, plus 1. Let's see if it would make the statement be greater than 7. A negative times a negative will give us a positive. Remember that. When we multiply two negatives, it gives us a positive. So that's 4 plus 1. 4 plus 1 is actually 5. Is 5 greater than 7? No. So that would not make the statement true. So we're seeing that if we chose a number that's greater than negative 2, and the number did not give us the solution that we're looking for. So what am I going to do? I'm going to check to see, what if I chose a number that was on the other side? What if I chose a number that was actually greater than greater than, less than negative 3. Let's choose a number down there. All right, so we see that when I chose a number, when y was greater than negative 3 and I chose a number from that set, we realized that the solution did not work. It never met this statement true. So now I'm going to flip the script and say, what if y was actually less than negative 3? What if that was the solution set? Let's choose a number, y being less than negative 3. Looking at the number line, a number less than negative 3 means we're going to the left. And this would be negative 4, negative 5, negative 6. So I'm choosing one. I'm just going to choose negative 4. If y is equal to negative 4, from this statement, let's see if that would make the statement true. If 2 times negative 4 plus 1, let us check to see what is that value. A negative times a negative is a positive, and that gives us positive 8 plus 1. Positive 8 plus 1 is 9. That would definitely make the statement true because 9 is greater than 7. What we wanted to find was what value of y would make this statement true. Now, when we solve the equation using our regular method, we realized that solving the equation, we would have gotten a statement here that says y is greater than negative 3. But if you look at the fact that it was a negative number that will now multiply y, because a negative number is multiplying y, and if you look at what the solution of y is, when you substitute the negative, it causes you to have a negative multiplying another negative, which means that this will now become positive. Because of that and how the solution applies, it therefore means that I can confirm that if you have an inequality and the coefficient of your variable is a negative number, the solution that you get must be the opposite symbol here. So this statement is not true because it would not make that statement true. It therefore means that I need to flip the sign. So it therefore means that y would be less than negative 3, and that would make the statement true. So what can I now conclude? I'm going to repeat the statement. If you have an inequation where the coefficient of your variable that you're trying to find is a negative number, when you write the solution for that variable, it means that the sign that was originally there must be flipped in order for that number to make the original statement true.